The narrative of the universe's formation and evolution has closely followed the significant advancements in space exploration technology. Through the Hubble Space Telescope, we've uncovered surprising truths: the existence of stars, galaxies, and supermassive black holes much earlier in the cosmic timeline than previously thought, and their subsequent dramatic transformations. We've also discovered that dark matter and dark energy are the primary architects of the universe's structure. The Kepler telescope and its counterparts have revealed a universe adorned with diverse planets, much like ornaments on a Christmas tree, including countless worlds in our own Milky Way that could potentially support life. The advent of the James Webb Space Telescope marks a new era in our cosmic journey. Peering deeper into space than ever before, it's revealing aspects of the universe, from exoplanets to supermassive black holes and the earliest stars and galaxies, in ways we've never seen. 2 years into its mission, the James Webb Space Telescope has profoundly altered our perception of the cosmos. We'll explore the most breathtaking images it has captured and the new insights it has provided about the previously unreachable corners of the universe. Join us in delving into how the James Webb Space Telescope is reshaping our understanding of the cosmic narrative. In recounting the history of star formation in the cosmos, the story typically unfolds like this. In the beginning, the universe was devoid of stars. The earliest phases saw the formation of protons, neutrons, atomic nuclei, and eventually neutral atoms. It then took tens or hundreds of millions of years for these initial clouds of gas to gain sufficient mass through gravitational forces to enable their collapse, an event that ignited the birth of the first stars. These early stars were composed solely of hydrogen and helium. However, the life cycle of these first-generation stars was not eternal. Many ended their existence in spectacular stellar explosions known as supernovae. The nuclear reactions that took place within these stars, both the steady fusion occurring in their cores during their lifetimes and the rapid reactions during their explosive demise, collectively contributed to the composition of the material these stars returned to the interstellar medium. This ejected material, now enriched with new elements, blended with the remaining interstellar medium, creating a vast cosmic recycling system. From this enriched interstellar medium, new generations of stars emerged. With each cycle, the interstellar medium became increasingly rich in elements, fostering the birth of stars with ever more complex compositions. This process marks the continual evolution and enrichment of the cosmos. The continuous enrichment of the universe over time presents a fascinating perspective for understanding how the universe and the stars within it have evolved from their early stages to the present day. Currently, we exist in the here and now, but the stars we observe are not just those forming at this moment. They encompass all stars that have formed throughout the universe's history and are still shining within our observational reach. If our aim is to comprehend the earliest stars in the universe, we have a few strategies. One approach is to look as far away as possible, attempting to detect the earliest stellar populations back at the epochs when they were just beginning to form. Alternatively, we can examine the oldest, most unaltered relic stars closer to us, seeking insights into the universe's state at the time of their formation by analyzing their current properties. The James Webb era has ushered in a treasure trove of data about the early universe. In less than 2 years since its launch, the James Webb Space Telescope has revolutionized our perception of the cosmos. It allows us to peer into distant dust clouds and observe light from remote corners of the universe for the very first time. Each new image we receive is a revelation, enhancing our understanding of the cosmos and its intricate history. This new discovery is empowering scientists worldwide to explore and answer questions that were once unimaginable. The field of astronomy is buzzing with excitement over the revelation that among the celestial bodies captured by the telescope's expansive mirror is the oldest known galaxy in the universe, known simply as JGS 13. This galaxy is observed as it existed just 320 million years after the Big Bang long before our own planet was formed. Remarkably, while it's much smaller than our Milky Way, it was forming new stars at a rate similar to our galaxy. This prolific star formation isn't unique to JAY's Gs13. Several other ancient galaxies photographed by the James Webb Space Telescope are demonstrating similar traits. Professor Brant Robertson, an astrophysicist at the University of California, Santa Cruz, commented on this, noting that despite their youth, these galaxies were already bustling hubs of star formation. This finding is also echoed with enthusiasm by Kevin Hanline, an astronomer at the University of Arizona, Tucson, highlighting the remarkable nature of these early cosmic structures. Kevin Hanline, an astronomer, expressed his excitement about the observations of the earliest galaxies in the universe, describing it as a thrilling development that has opened a new chapter in the history of astronomy. These observations are reinforcing the idea that the universe was dynamic from its inception. While the photographs of the Ro-Ayuchi star field are undoubtedly impressive, it's the more subdued images of JD's Gs13 and its ancient companion galaxies that are sparking real excitement among cosmologists and astrophysicists. These observations are seen as a testament to the true potential of the James Webb Space Telescope. Sandro Tacella, an astrophysicist at Cambridge University, noted the astonishing level of detail the telescope has revealed about the early universe. Theoretical predictions had suggested complex cosmological processes would be occurring at this early stage, but the clarity and precision of the telescope's images have allowed scientists to actually observe this complexity in action. This has been both surprising and gratifying. Furthermore, the James Webb Space Telescope's glimpses into early galaxies could provide new insights into dark matter. Dark matter, an enigmatic and invisible form of matter, has long puzzled scientists, and these new observations could be key in unraveling some of its mysteries. Dark matter is believed to constitute about 27% of the known universe, outnumbering visible matter by approximately a 6-to-1 ratio. Despite its significant presence, dark matter has remained elusive since its existence was first proposed in 1933 by Fritz Zwicky, a Swiss-American astronomer. To date, dark matter has never been directly observed. The James Webb Space Telescope, while unable to directly detect dark matter, offers scientists the potential to study its effects on surrounding environments. By doing so, Webb could answer some major questions about dark matter, significantly advancing our understanding of the universe. A key question is how dark matter influenced the formation of galaxies in the universe's infancy. For the first few 100,000 years after the Big Bang, the universe was too hot for gravity to pull normal matter into large protogalactic clumps. Jorpanur Ruwaya, a cosmologist at the University of Edinburgh in Scotland, explains that this was not a problem for dark matter. Unlike normal matter, dark matter does not interact via electromagnetic forces, but is governed solely by gravity. This means that shortly after the Big Bang, in the midst of primordial chaos, dark matter could begin to exert its influence, guiding the early formation of cosmic structures. Gravity swiftly began clustering dark matter into large structures known as halos. These dark matter halos are thought to have served as gravitational wells for normal matter, seeding the formation of galaxies in the early universe. The movements of stars within these halos provide evidence of their persistent influence, with such halos still surrounding galaxies, including our own Milky Way, shaping the cosmos in an invisible yet majestic manner. The James Webb Space Telescope's rapid discovery of early galaxies is challenging our understanding of how these halos formed, suggesting they may have attained immense size earlier than previously thought. This raises questions about the fundamental nature of dark matter. While simple models, where dark matter only interacts with itself and normal matter through gravity, can replicate large-scale cosmic structures, reality may be more complex. There's a possibility that dark matter interacts via an unknown force, potentially through a particle not yet included in the current standard model of physics. This could explain the rapid growth of these halos and shed light on how bright, massive galaxies formed so quickly in the universe's history. In summary, while there are various hypotheses about how cold dark matter could resolve the conundrum presented by the early galaxies discovered by the Webb Telescope, one of the intriguing aspects of exploring alternative dark matter models is the chance to uncover new phenomena that can be empirically tested. In this context, the James Webb Space Telescope might play a crucial role in identifying and studying some of the universe's earliest dwarf galaxies. By comparing the actual size, shape, and chemical composition of these galaxies with the predictions made by different dark matter models, scientists hope to determine which model of dark matter is accurate. A vital tool in this endeavor will be the use of massive cosmic structures known as gravitational lenses. Despite the grand name, these are essentially galaxy clusters so massive that they bend the space-time around them, amplifying the light from distant objects behind them. Utilizing the James Webb Space Telescope to observe through these gravitational lenses, which are fortuitously aligned with distant early universe galaxies, astronomers hope to catch a glimpse of the light from small primordial satellite galaxies. This could provide crucial insights into the elusive nature of dark matter. 4. Furthermore, the James Webb Space Telescope is dedicating a significant portion of its valuable observation time to investigating these mysterious aspects of the cosmos, underscoring the telescope's pivotal role in advancing our understanding of the universe. In its latest observations, the Webb Telescope has revealed new aspects of Beta Pictoris, a young planetary system in unprecedented detail. It has captured a previously unseen structure resembling a dusty cat's tail. Beta Pictoris, situated 63 light-years away from Earth, is a star about twice the size of our Sun and 8 times brighter. This star is encircled by a disk of gas and dust, within which there is evidence of planet formation. Beta Pictoris was the first planetary system where astronomers observed a dusty disk of material composed of debris resulting from the collisions of asteroids and planetesimals during the system's tumultuous early years. Following this, the Hubble Space Telescope enabled astronomers to identify a second disk of debris and material within the Beta Pictoris system. Now, with the advanced instruments of the James Webb Space Telescope, specifically the INCOM and MIRI, a team of astronomers has uncovered yet another layer of complexity in the system. They have discovered a distinctly angled branch of dust extending from the southwestern part of the secondary debris disk. Isabel Rebolo, the leader of the study team and a scientist at the Astrobiology Center in Spain, remarks on the uniqueness of Beta Pictoris, noting its exceptionally bright star and the comprehensive features of its debris disk, making it a particularly fascinating subject for astronomical study. The study of Beta Pictoris has been significantly enhanced by the capabilities of the James Webb Space Telescope. While previous ground-based observations in the same wavelength range existed, they lacked the sensitivity and spatial resolution that Webb offers, and thus failed to detect certain features. The cat's tail structure of Beta Pictoris, for instance, was only visible to the MIRI instrument on Webb as it shines brightest in mid-infrared light, which may explain why it had been overlooked previously. In addition to this discovery, Isabel Rebolo and her team observed a temperature difference between the two debris disks of the Beta Pictoris system, suggesting they might have different compositions. Christopher Stark of NASA's Goddard Space Flight Center in Maryland, a co-author of the research, noted the unexpected revelation by the James Webb Telescope that there are two distinct types of material in the Beta Pictoris system. The MIRI instrument clearly showed that the material in the secondary disk and the cat's tail is hotter than that in the main disk. This implies that the dust forming these structures is very dark and not easily visible at visible or near infrared wavelengths. However, in the mid-infrared spectrum, it is clearly glowing. The team is now theorizing about the different compositions of these disks, potentially leading to new insights into the formation and evolution of planetary systems. The research team hypothesizes that the disk with the hotter temperature in the Beta Pictoris system consists of dark, highly porous material. This material is similar to the organic refractory material found on the surfaces of comets and asteroids within our solar system. While animal behaviorists believe that cats curve their tails as a form of greeting or to express friendliness and playfulness, Isabel Rebolo and her colleagues are still trying to understand what causes the curved cat's tail shape in this cosmic context. This curved feature is not commonly observed in the debris disks of other planet-forming systems. To solve this intriguing puzzle, the team simulated several scenarios to replicate the cat's tail structure and decipher its origins. However, the feature's uniqueness posed a challenge. As Christopher Stark explained, reproducing the curvature dynamically was difficult. Their model suggests the need for dust that can be rapidly expelled from the system, supporting the idea that it's composed of organic refractory material. Further investigation led the team to conclude that the cat's tail likely resulted from a dust-producing event that occurred roughly 100 years ago from our perspective on Earth. This insight was also shared by research co-author Marshall Perrin of the Space Telescope Science Institute, highlighting the dynamic and ever-changing nature of planetary systems and the complex processes that shape them. Marshall Perrin, based in Baltimore, explained the dynamics behind the unique dust structure observed in the Beta Pictoris system. According to Perrin, a collision likely occurred, generating a significant amount of dust. Initially, this dust traveled in the same orbital direction as its source, but over time, it began to disperse. Perrin noted that the star's light exerts a force on the smallest and fluffiest dust particles, pushing them away from the star more rapidly. In contrast, larger grains, which are harder to displace, don't move as much. This disparity in movement results in the formation of a long, trailing tendril of dust. Regarding the sharp angle at which the dust tail diverges from the debris disk, Isabel Rebolo and her colleagues believe this might be an optical illusion caused by the perspective from which the James Webb Space Telescope observed Beta Pictoris. They estimate that the actual angle at which the dust trail extends from the debris disk is only about 5 degrees. By analyzing the brightness of this newly discovered feature, the astronomers were able to deduce that the amount of dust in the tail is roughly equivalent to the mass of an average asteroid found in the main belt between Jupiter and Mars, yet it's spread over an astonishing length of approximately 16 billion kilometers. The event that created Beta Pictoris's distinctive cat-like feature might also be responsible for another interesting aspect of the system. The researchers speculate that the same collision could be linked to other unique characteristics observed in Beta Pictoris. Another intriguing possibility arising from the dust-creating event that shaped Beta Pictoris's unique features is its potential connection to an asymmetry observed in Beta Pictoris back in 2014. Using the Atacama Large Millimeter/Submillimeter Array, ALMA astronomers detected an asymmetry in the form of a clump of carbon monoxide situated near the cat's tail. Normally, radiation from the central star should break down this carbon monoxide clump within a century. The fact that the gas concentration still persists could be indicative of the same event. Christopher Stark concluded that their research suggests Beta Pictoris may be even more active and chaotic than previously thought, highlighting the capacity of the James Webb Space Telescope to reveal new insights about even the most well-studied celestial objects. It continues to provide us with a fresh perspective on these planetary systems. Shifting focus, there have been rumors circulating within the astronomy and astrobiology communities regarding the possibility that the James Webb Space Telescope has made a groundbreaking discovery of a planet with strong evidence of life. These speculations have been circulating for a while, gaining traction in reputable circles. Recently, they garnered public attention when the British news magazine, The Spectator, published an article titled, "Have We Just Discovered Aliens?" This publication featured discussions about the potential discovery, sparking curiosity and discussions about the implications of such a finding. Renowned British scientists, including astrophysicist Rebecca Smithurst, have expressed anticipation regarding an upcoming scientific paper that is expected to present strong evidence of a potential biosignature on an exoplanet. Smithhurst commented, "I think we are going to get a paper that has strong evidence for a biosignature on an exoplanet very, very soon." These statements have generated considerable interest and excitement. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q and a sessions with experts. Your membership will grant you the chance to participate in live Q and a sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.